my PhD work was kind of more focused on of remyelination and focusing on how microglia phenotypes and functions change in efficient remyelination. So it was more in the context of multiple sclerosis, but we know that remyelination or myelination is also affecting Alzheimer's disease. And what was really shown by my PhD supervisor, Professor Véronique Miron, was really showing how microglia drive remyelination and how important they are in this function. And this again really highlights that, even in this kind of in this disease context, there are still what were classically known or thought to be good and bad microglia populations, and bad usually was associated with inflammation and good was associated with kind of repairing the brain. But actually that paper showed that there was a really important kind of balance between this early initial activation of microglia after demyelination. And these microglia are very inflammatory, but they were needed. They were really important to kind of clear up that initial damage. And then to really efficiently kind of regulate inflammation, these microglia died by necroptosis, which then led to the activation of these pro-repair microglia that promoted remyelination. So even then, it was kind of seen then as kind of a binary, early and late, these microglia activated phenotypes. But even then, although we didn't have the kind of single cell, we were already kind of showing that, there were different populations of microglia that played really important but different roles in repair. And that's something that we're kind of realizing in Alzheimer's disease as well, is that there are very different responses of microglia functions and phenotypes in kind of the early initial stages of Alzheimer's and in these early models. And this really changes as disease progresses. What we don't know is how and why the microglia in Alzheimer's disease change and how they go from kind of this early activated phenotype, which is associated with a little bit of efficient clearance of amyloid plaques, a little bit of neuro repair. And then as the disease progresses, we see less of that, and we see that microglia become less efficient at clearing these plaques away and clearing kind of dying cells, and become much more inflammatory, much more pathological, and seem to really promote neurodegeneration. And so although my PhD paper is not related to Alzheimer's disease completely, actually really gave me that kind of inspiration to really look at microglia phenotypes and functions in Alzheimer's disease. And so that's kind of, it is quite kind of nice complementary follow-on to that, where we're still looking at how these phenotypes and functions are important in Alzheimer's disease, but we really want to look at them kind of in a more unbiased approach by looking at their whole proteome to see if we can pick out any kind of differences in pathways that are activated that maybe previously we wouldn't appreciate, because that's the beauty of having kind of a proteomic resources. We can look at this completely unbiased and pick out these pathways that might not have been appreciated before as maybe novel therapeutic targets. And